In this video, we are going to solve the Codeforces problem number 263A, or the beautiful matrix problem. At first, let's understand the question. In the question, we are given a 5 by 5 matrix. Now we know a 5 by 5 matrix has 25 elements. It is given that 24 elements of the given matrix are 0 and the remaining element is 1. But we don't know exactly which element of the matrix is 1. Now, according to the question, a beautiful matrix is a matrix that has the number 1 in the 3 by 3 position. Now, we are given a matrix and we need to swap the rows and columns of the matrix to transform the matrix into a beautiful matrix. Then, we need to print the minimum number of moves that are needed to convert the given matrix to a beautiful matrix. But we are given a constraint here, that is, we can only swap one row or one column of the matrix in one move. Now let's see how we can solve this problem. To solve, we will consider the matrix as a 5 by 5 2D array. So both the number of rows and the number of columns will start from 0 and end at 4. Therefore, in a beautiful matrix, the element 1 will be situated at the 2, 2 index. Now we will be given a matrix in which we do not know the position of the element 1. So at first, we will need to find the position of 1. For that, we will perform the linear search and find the row number and the column number of the element 1. Then we need to determine the number of moves needed for the element to reach the 2, 2 index. Now let's take a not so beautiful matrix. In this matrix, element 1 is situated at the 0, 4th index. Now let's start swapping. We will first swap the 4th column with the 3rd column. So that is our move 1. Then we will swap the 3rd column with the 2nd column, and that is move 2. Now that the number 1 has come to the 2nd column, we don't need to swap the columns anymore. Now we will start swapping the rows. So swap the 0th row with the 1st row and then swap the 1st row with the 2nd row. So that is 2 moves. And after these 2 moves, we can see that the number 1 is in the 2, 2 index. So we have converted the matrix to a beautiful matrix, and we needed a total of 4 moves to do that. So in this case, our answer will be 4. Now look at the given matrix again. Initially, the element 1 is situated in row 0 and column 4, and its final position should be in row 2 and column 2, which is fixed in every case because that is the position where the element 1 needs to be to form a beautiful matrix. So here the initial row number is 0 and the final row number is 2. Similarly, the initial column number is 4 and the final column number is 2. Now, if we subtract the initial row number from the final row number, we get the row to row distance, which in this case is 2. Similarly, if we subtract the initial column number from the final column number, we obtain the column to column distance. But wait, the distance can be negative, so we put a modulus here. That means we calculate the absolute value. Now, if we add up the row to row distance and the column to column distance, the sum is 4, which is the answer in this case. So we can just determine the row to row distance and column to column distance and add them up to get the number of moves we need to convert a matrix to a beautiful matrix. We start with creating a 5 by 5 2D array. Let's name it A. So int A 5 5. Now we need to take input in the array. For that, we have to create a nesting loop for int I equal to 0, I less than 5, I plus plus, and then another loop inside. And we will take input C in A, I, J. After that, we need to perform the linear search in order to get the initial row number and column number of the matrix. For that, let's create 2 variables. We will store the initial row number in the row variable, and we will store the initial column number in the column variable. Now we need to create another nesting loop. Now we will check if the value in the index is equal to 1. So for that, if a I j equal 1, if the value in the index is equal to 1, we will store the value of row, that means the value of I in the row variable, and we will store the value of j in the column variable, and then we can just simply break from the loop because we will get the value 1 in only one index. Then we can create a variable ans to store the final answer, and here we need to store the row to row distance and the column to column distance. So as we discussed earlier, we need to store the absolute value. So for that, we have a built-in function in C++ that is abs, and inside the parenthesis we can just write row minus 2 plus abs column minus 2, and after that we can just simply print the ans. New line, and that's it.